Dear students, today we are going to study about measurement and its units. Why measurement is important? To measure something is very important, especially in chemistry and physics. In chemistry, we need measurement for standardizing the solution, making the standard solution, and stoichiometric calculations, and so many other measurements are there. So whenever we are talking about the measurement, we need some units. What is unit? Actually, if you talk about the unit, then unit is nothing more than a standard. It is a standard that is described by certain agencies or the organizations. The word unit has been derived from unus. What is unus? Unus is a Latin word which means uniform. So unit describe particular measurement. Even the quantity is not written there. You can find the which quantity is described here. For example, gram is the unit of mass. So if I told you that I have 2 gram table salt, so you can easily understand that it is the mass. Mass is given here. If I ask you to bring 1 liter of milk, so definitely I'm talking about the volume because liter is the unit of volume. So today we will study different units and their standards. So we should see what is unit. The standard definition of unit is it is the smallest quantity that describes the whole quantity. So it is our standard that any unit, for example, gram, liter, or anything else, it describes the whole quantity, but we show it in a small quantity. So the small quantity that describes the whole quantity is called unit. Now see, if you say something is, for example, 2 gram table salt or anything 10 gram table salt. So what does it mean? If you know the quantity in 1 gram, then you can understand how big would be the 10 gram. Similarly, if you know how much is 1 liter, then you can understand if something is 10 liters, so how much quantity would be there. So this small quantity that is represented by liter, gram, or in measurement, for example, if you know how long is 1 meter, so how much a kilometer, you can understand it. So for estimating and accurate calculation in both the cases, you need small quantities to represent the whole quantities. So this is the concept of unit. And now we will see some standard units. Uh, first we will see how many types of units are there. So now see there are two different systems of unit. There may be more than two, but two common systems are British engineering system and the metric system that is also called the system international units. For example, in most of the world, mass is measured in kilogram, but in British system, mass is measured in pound. So similarly, there is a difference between the British system and the System International. System International was developed for the uniformity in measurement all over the world because measurements are necessary in all the scientific works and not only in scientific work but in other fields as well. So there should be the uniform system. Otherwise, you would not get the correct measurement and you will be confused. For example, if I told you to bring a cake, uh, a cake of 2 kg, so but in British system, there is the pound. So if I ask you to bring a cake of 2 kg and you find on the bakery and you see that the shopkeeper is asking about pounds, then you will be confused. You have to calculate, you have to convert the unit. So that's why we need to study the conversion of units as well. But first, we will study different fundamental and the drive units in System International. Then we will go to some existing unit in the world and we do calculations for converting these units. Okay, so first we will start. We are going to discuss matrix system or the System International. So in metric system, it is the internationally adopted system for units for scientific purpose based on tens. What does it mean? So see, okay, so you should see here what does it mean that it is based on tens. Actually, wherever we use the term m, for example, milligram. So what does it mean? Milli means 10 raised to power minus 3. And if you talk about kilo, so kilo is 10 raised to power 3. So in milligram, it means it is 10 raised to power minus 3 gram. And if you talk about kilogram, 1 minute. Okay. So if you talk about kilogram, it means it is 10 raised to power 3 gram. Similarly, if you are to calculate or you have to convert kilogram into gram, for example, if it is a very small quantity, that's 0.04 kilogram, so better to write it in gram. So what will you do? You just replace k with the 10 raised to power 3. So it becomes 0.04 into 10 raised to power 3 gram. So when you multiply this, it would be 40 gram. So 0.04 kilogram would be equal to 40 gram. So it is an easy method to convert larger unit to the smaller unit or a smaller unit to the larger unit. For example, if quantity is given, for example, 20 to 50 gram, not 250 gram, for example, 25,000 gram. So better to use instead of gram, you should use kilogram. So what is the relationship between kilogram and gram? You know, 1 kilogram is equal to 10 raised to power 3 gram. How do you know? Because this K stands for 10 raised to power 3 from this metric system that is based on tens. So if we are talking about 1 gram, how much gram would be equal to kilogram? So put it here. It is 1 upon 10 raised to power 3 kilogram is equal to 1 gram. So you are to convert this into kilogram. Remember that this is the power. Okay, I should write 3 very small. Okay, so you are to convert 25,000 gram into kilogram. I will teach you in detail the dimension analysis for conversion of unit, but right now I'm just telling you, okay, what does it mean by that it is based on 10? So you need in kilogram must be in denominator in numerator, and gram must be in numerator. Sorry, in denominator. So 1 kilogram is equal to 10 raised to power 3 or the 1,000 gram. So you know this these 30 are also equal to 1,000. So you can write whether 10 raised to power 3 or the 1,000 completely. You can see here 10 raised to power 3 is equal to 1,000. So from these 30 have been cancelled. So this 25,000 gram is equal to 25 kilogram. How? Because gram is in denominator and here it is in numerator, so it has been cancelled. So what is remaining here? Remaining here is kilogram. So in this way you can easily convert the unit as well. So here we are talking about why it is called matrix system. Matrix means that is based on 10, and you can see in this table decim is 10 raised to power 1, that is 1/10. Centim is 10 raised to power minus 2, that is 100th. 100th means 1 upon 100, and 1 upon 100, if you calculate, you will get 0.01. Similarly, milli, that I have already told you here, milli is 1,000. 1,000 means 1 upon 1,000. Remember that the difference between the word 1,000 and thousandth, if you add th, so it becomes the reciprocal of 1,000. So it is 1 upon 1,000. Similarly, million is the mega, that is 10 to the power 6, but the millionth, where is the million? Millionth is here. So millionth is 10 to the power minus 6, that is the reciprocal of the million. Million means 10 lakh. So reciprocal of 10 lakh is 1 upon 10 lakh. That is 10 raised to power minus 6, and it is known as micro. Similarly, nano is also based on 10. So it is 1 billion. 1 billion means 1 upon 1 billion. 1 upon 10 raised to power minus 1 upon 10 raised to power 9. And what is billion? Billion is gigahertz. You have noticed the word gigahertz. So here giga is billion, but nano is billion. And similarly, you can see other quantities as well. But what we usually use is mega, kilo, very rarely hecto, deca, and deci, 1/10, centi, milli, micro, and nano. These are uh, these are commonly used in our calculations. Okay, but we don't use rest of the prefixes. These are called the metric prefixes. So only these are the common prefixes that we will use in our calculations. Okay, so in next we will see some fundamental units and what are the difference between fundamental and the drive units. Okay, let's see. Okay, I was telling you that there are two types of quantity: fundamental quantities and the drive quantities. Fundamental quantities have single unit. What does it mean? When I will tell you drive unit, then it would be more clear. So these are the fundamental units. Mass, the unit of mass is kilogram. The standard unit is kilogram, and its symbol is small k and g. Length is meter. Small m is the symbol, abbreviated. Uh, this is the symbol, not abbreviation. Okay. Time is second. Small s is the symbol. Electric current, ampere, capital A. Temperature, Kelvin, capital K. See, for kilo it is a small k, and for Kelvin it is capital K. And there is no degree sign. Luminous intensity is candela, small c, small d. And amount of substance is mole, and its symbol is MOL. The spelling of mole is MOLE, but the symbol is small m, small o, small l. So these are the fundamental quantities, and you can see these have the single unit. But there are some drive quantities. Drive quantities, because these are derived from the fundamental quantities. So what are drive quantities? For example, you can see volume. Volume is a drive quantity because if you talk about the volume of a cube, then volume of a cube has three lengths to be multiplied. I tried it to make a cube. You can consider it. For example, this length is 2 centimeter. It is also 2 centimeter. And this one is also 2 centimeter. If you are confused what three measurements could be taken, so take any one point and take all the three lines emerging from that point and measure these. So this is equivalent to this. This is equivalent to this 2 centimeter. So in cube, all the three lengths are equal. So it is the multiple of three lengths. So L into L into L is equal to L cube. See, L into L into L is equal to L cube. So the measurement would be 2 centimeter into 2 centimeter into 2 centimeter. Or in simple way, you can write 2 centimeter cube, because L into L into L is equal to L cube. So this cube is for this centimeter and 2 as well. So 2 to the 4, 4 to the 4 twos are 8. So it is 8 centimeter cube. So the unit of volume here is centimeter cube, and uh, how is it derived? It is derived from the fundamental unit. Similarly, for volume of a rectangular block, for example, if you have a rectangular block, then you have three lengths. One is this. For example, it is 2 centimeter. Another is this. Suppose, because exact measurement, I don't have exact measurement here. So suppose it is 8 centimeter. And this line that is equivalent to this line, it is 3 centimeter. So in this case, it is L into B into H. So you can consider this is L, this is B, and this is H. So L is 8 centimeter, B is 2 centimeter, and H is 3 centimeter. So multiply these. 8 to the 16, and 16 threes are 48, and there are 3 cm, so it becomes cm cube. So again, you have the drive unit. Another important quantity that is drive quantity is density. So see, what is density? Density is mass upon unit volume. So the mass of unit of density depends on mass and the volume. If the unit of mass is taken gram and unit of volume is taken centimeter cube, so the unit of density would be gram per centimeter cube. You can write it like this: gram centimeter cube inverse. So now you can understand what is meant by the derived quantities and their units, and what are fundamental quantities. So for fundamental quantities, you just memorize these, and if you forget, then see this table again. Don't worry about it. But for drive unit, you need a formula and to put the correct unit over there, and we will see in our calculations. So from this description, you can understand that there are so many advantages, and two are the more important. Number one, it is used all over the world, except United States, because other units are also used there. But in scientific calculation, we always follow the system international, even in United States as well. In mathematics, these calculations by using the system international, these are more easier because by using the power of the 10, as it is based on the tens, so we can convert the smaller units into the bigger unit very easily. One of the example I have given here, and we will see in our calculations, in our examples, inshallah ta'ala. Okay, so in next video, we will see certain calculations.